Hello everyone. In my previous lesson, I have shown you how to come up with two numbers, which when you multiply them together, you get the constant term. And when you add them together, you get the coefficient of x while factoring quadratic expressions. So these are the steps. You take the coefficient of x, you divide it by 2, you square that. You bring back the constant term. Then after simplify this, you get 1, you bring it back here. You have to subtract it. Simplify, in the end, you're going to get the two numbers, which eventually we plug back. The same thing here. But some people ask, what if the leading coefficient is not 1? So in this tutorial, I'm going to show you how to do that, as well as how to apply the same idea to factorize even those expressions that are not factorable. Let's get started. All right, here are our three problems. The first one is already factorable. This is not. And this even contains complex roots, but I am going to show you that all of them are factorable using the same idea. Let's start with the first one here. Since we have the leading coefficient as 2, we have to factor it outside. 2 outside, inside. We have all of this divided by 2. Starting with this one, x squared. Minus 5 divided by 2, x. Plus 3 divided by 2. We have divided all of them by 2. Now you can see we have no leading coefficient here because we are going to pay attention to this. Then in the end, we multiply by 2. All right, bring down the coefficient of x, which is negative 5 divided by 2. But you know you're going to divide it by 2. By dividing this by 2, it becomes 4. Remember to square everything. Bring down the constant term, 3 divided by 2. Now subtract the result here. This is going to give us 25 over 16, right? 25 divided by 16. Negative 5 divided by 4 whole squared will be what? We can make this one 16 by multiplying by 8, but remember you have to multiply the top by 8. 3 times 8 is 24, and 24 minus 25 is negative 1. So we have negative 1 divided by 16. But we know that negative 1 divided by 16 is the same thing as negative 1 divided by 4 whole squared. Because 4 squared is 16, 1 squared is 1. So instead, we can write this one as 1 over 4 whole squared. Yes, this is nothing but difference of two squares. How do we factorize it? You take this minus, should I do it directly? Minus 5 over 4 minus 1 over 4 will give us minus 6 over 4. Minus 6 over 4 multiplied by, now you add. Previously we subtract, now we add. Remember this, a squared minus b squared is equal to what? A minus b times a plus b. Difference of two squares. So since we subtracted, now we're going to add. Negative 5 over 4 plus 1 over 4 will give us what? Minus 4 over 4, which you can simplify later. So the factorized version of this will be 2 times, remember this 2 is there, x. The first number is this one, which can be written as 3 divided by 2, negative 3 divided by 2, right? Negative 3 divided by 2. Then the second one, x minus 1, because negative 4 over 4 is minus 1. And we are done. If you like, you can expand this number inside. So we have 2x minus, this will give us 3 because the 2's will cancel. Therefore, the factorized version of this is this. Why do we use this method? In case of larger numbers, sometimes this number can be very huge that you cannot easily think of two numbers to multiply together to get that. So instead, you can apply this strategy. Let's come to the second one. All right, the leading coefficient is already 1, so we have no problem with that. Take this number 4, divided by 2 and square that. Bring down the constant term, then subtract the result here. 4 divided by 2 is 2. 2 squared is 4, right? Then this remains 2 squared minus 6. But this is not difference of two squares. How can we attach power of 2 here? We can do that confidently by taking the square root of this number, then square that. Eventually, power of 2 will cancel the square root. So this is what we have as difference of two squares. So that we have 2 minus root 6 times 2 plus root 6. You see that these are the two numbers you can multiply together to get this and add together to get this. All right, therefore, to factorize this, you form your two factors x. The first number is 2 minus root 6. The second number is what? 2 plus root 6. We are done. Then the last one. The last one contains complex roots, but notwithstanding, we are going to see how we can factorize it. Remember, I told you every form of quadratic expression is factorable, provided you can follow this strategy. So you bring 2 outside, you divide all of them. We have x squared minus x plus 3 divided by 2. Pay attention to this one. The coefficient of x is negative 1. So bring that negative 1 divided by 2, square that. Then bring the constant term, 3 divided by 2. Subtract the result here. This will be negative 1 squared is 1, 2 squared is 4, so we have 1 over 4. Simplify this. Times this by 2 to make it 4. Times this by 2 to make it 6. 6 minus 1 is 5. So we have negative 1 over 2. Then plus 5 over 4. Two problems. We don't have minus here, and this number is not squared. How do we do that? Let me start with the squared. I can confidently add square root here and square that. Now we have sum of two squares, but we need difference of two squares. But we know that minus can be written as, sorry, this is plus. Plus can be written as minus times minus. So instead, I can write this one, I beg your pardon, as minus times minus, what? Square root of 5 divided by 4 whole squared. Because I know that minus 1 is the same thing as I squared. So I'm trying to introduce difference of two squares. So instead of this minus, I can attach I squared. You see the logic? Now we have difference of two squares. Because this has a power of 2, this has a power of 2, you can even join them together so that all of them have the same exponent of 2. Now it will be this minus this. Another thing I can do here, we know square root of 4 is 2. So why not just take square root of 5 and change this to 2? You see the logic? Now, what will be this minus this? It will be minus 1 over 2 minus root 5i divided by 2 times minus 1 over 2, then plus root 5i divided by 2. And these are our two numbers. All you have to do is to attach, what do we call it, x. But let me simplify this. What do you see here? Because we have the same denominators, I can write this one as minus 1 minus root 5i divided by 2 times, do the same thing here, minus 1 plus root 5i divided by 2. So next, factorize it. We have x, bring this minus 1. I can add plus here. I'm going to explain. Because this minus is affecting everything here. Minus 1 minus plus this will make it minus again. So we have no problem with this. Then do the same thing here. X minus 1 minus root 5i divided by 2. The same thing. If minus affect 1, it becomes minus 1. If minus affected this one, it becomes plus. So this is the factorized version of this. Oh, we have 2 outside. Don't forget. Don't forget we have 2 outside. Now, if you like, you can expand so that it becomes 2x minus, so it is going to become like this, minus 2 times this one. 2 will cancel this one automatically. So you have minus 1 minus root 5 because we have no denominator. Then times this other one. But since we don't have much space, let's leave it like this. 2 times this is the factorized version of this. As simple as that. Thank you for watching. Do share to your learning colleagues. Bye-bye.